For the Carpentries and Future Works, and the host of the Humane podcast, which is an AI podcast that shares consumer trends from industry-leading executives at Fortune 500s and startups in the fourth industrial revolution. We're just going to ask you to hold the applause until the end. So our next panelist is Osho Jha. He is the senior data scientist at a long-short equities hedge fund. He has over 9 years of experience as a data scientist and has published research and built trading strategies, leveraging alternative data to understand e-commerce consumer trends. Outside of financial services, he first encountered the confluence of mathematics, statistics, and computer programming that we now call data science in 2009 at Raytheon BBN Technologies Speech and Language Technologies Lab, where he worked on speech-to-speech translation systems as part of a DARPA contract. He is a Carnegie Mellon University graduate with a degree in mathematics and spent the majority of his undergrad pursuing grad-level research in theoretical mathematics and statistics. And finally, we have Ms. Bonnie Ray, who is the VP of Data Science at Talkspace, which is a digital health startup that enables mental health care for all by providing an affordable, accessible, and secure platform for message-based psychotherapy. Her experience includes leadership of data science activities at Arena.io, a hiring analytics startup, as well as an extensive career at IBM Research, where she led algorithmic development for next-gen AI applications. She has a PhD in statistics from Columbia University and a bachelor's in math from Baylor. And her expertise and passion is in extracting insights from data to address challenging business problems. Okay, and without further ado, let's give it up for our panelist and moderator.
Had such a great chats so far today. Some amazing information that Catherine and everyone shared with us, and so I thought it'd be great to talk about why text is essential to understanding your customers. Just the other day on Hacker News, on the front page, there was a headline that said, "The internet is an SEO landfill." There's so much text, we don't know what to do with it. We don't even know how to understand our customers. We started to hear today about 73 plus languages, design thinking around AI, how you can use programs like ConceptNet, Word2Vec2, and BERT to perhaps reinvent your NLP strategies. I'd like to start out with a question for all of our panelists, which is about common sense, the topic that Catherine spoke about tonight. You know, how can we build great systems for customers, for your companies, and how can you, and what are you doing today to retrofit your products to meet your customer needs? So I'd love to hear from each of our panelists. Catherine, if you'd like to start.
I talked a lot about this, or at least a little bit about this, in that kind of language. So using common sense and using NLP and more concept-driven NLP can be really helpful in actually understanding what people are saying when they use more exciting language.
Yeah, so I think like outside of usual numerical models, looking at textual models, the ideas that Dr. Bassi talked about using a knowledge graph really help kind of in financial services, it really help understand what your model is trying to predict. Because a lot of times you can run a model and it'll forecast something and it just doesn't make sense when you look at the outputs. So having this underlying knowledge graph to go back to helps out a lot of context and helps you spot predictions that just don't make sense.
Incorporating into the models is essential for what Talkspace does, because we are all about messaging-based psychotherapy. It's primarily text-based, and psychotherapy, trying to understand the psychotherapy process is all about trying to understand the emotions of the individual, how they're expressed, what domain these emotions are coming out in, how the individual is reacting, and the individuals are having conversations with their therapist. It's not an intent-based dialogue, really. It's more like a conversation. So we really need to have that general sort of common sense incorporated into our analysis of the language.
You know, this evolution of learning in NLP, we're talking also about topics like transfer learning for domain specialization. And in the AI space, there's so much domain specialization occurring. We just look at the startup arena. You can look at this whole new subfield called auto ML, which I'm sure many people have heard about, this new auto machine learning, which every platform claims to have, right? Google and Amazon and Microsoft. H2O and Data Robot and Paperspace, Weights and Biases, Spelled Out Run, Saturn, the names can just go on and on. Some of them, I'll share the links with you afterwards in the show notes. But we're seeing such an evolution of ML. And one term that one of my colleagues and I were talking about in Mountain View the other day is we think that the modularization of AI is the next wave that's coming. Just how we saw infrastructure as code become things such as Ansible and Terraform and all this modularization. Want to hear our panelists' thoughts on how the AI arena is evolving for deployment, perhaps at your companies or what you're seeing in the industry.
So we definitely see the need for having componentized sort of pipelines for data processing and modeling to make everything reproducible and to more easily iterate. That being said, I'm a little bit old school when I think about some of the auto ML because I still think it's sometimes people using auto ML maybe you still need to know the right questions to ask and to know how to look at what comes out of these auto ML processes and understand if it's correct. And so that's where I get a little bit worried. But having tools that help automate that whole pipeline is useful as long as you still have a human in the loop that's looking at what comes out.
Yeah, so I think there's this general kind of hope that one day we can have a model that you can edit into a data set and you can just figure stuff out, but maybe we're not there yet. I don't know if we're necessarily getting there. That domain expertise extends down to the data set level as well. As a data scientist, I meet fellow data scientists who really understand a few of the data sets they work with extremely well. Everything from outliers to other like statistical features about them. And so the models need to be built that way as well. So we have separate models running for different data sets. And I think we all came here to learn tonight. And I'm coming away with an idea that was presented in the talk about a neural network that kind of trains other nets. So
partners in Silicon Valley, and he's invested in 4 major AI companies: Keep Truckin', Cognata, Texi, Solvi. These are all billion-dollar AI companies, and a lot of what they've done to be successful has worked with synthetic data. In fact, these companies have solved what is called in the Valley as the cold start problem, having enough data to make progress. And so wanted to hear more about, do you think the cold start problem can be solved with synthetic data? Is it a hybrid approach with real data, crowdsourced and synthetic data? Or what can a solution look like?
I'm not sure that the problems can be solved entirely with synthetic data. I do think that a hybrid approach has potential. At Talkspace, we are very interested in how we can start to have to depend less and less on annotated or examples of the concepts that we're trying to learn how to identify automatically. So I'm very interested to hear and see where this work goes.
So synthetic data actually reminds me a lot about when Monte Carlo simulations first kind of became very popular. Granted, synthetic data and like generating those data sets is more complicated and generally more thorough. You still run into the simulation problem where it's just not applicable to everything you're trying to work on. So it's had great, it's been such a creative solution for like self-driving cars, right? I think I was reading about a company that was using video footage from Grand Theft Auto to train and test self-driving cars, which is kind of funny on its own. But you know, in like markets, for example, the way I see simulated data working is at best like a back testing engine, a way to test your risk metrics, a way to test how you're positioning your portfolio, but not necessarily something to train a model on right away.
So in language, I mean, very much agree with everything that both of the other two panelists have said. I think in language, synthetic data can be really hard because you're creating that synthetic data with a process, and almost always you end up, and then you're putting it against some of the really most sophisticated pattern recognition algorithms out there. And so what you end up doing is whatever patterns that were created by the system that created the synthetic data, you end up hyper-training on. And we've seen that happen a lot. I have a couple of very, very interesting specific examples that basically look at if you don't have a really good conceptual understanding, you will end up training like one intent, puppy always means one intent and dog always means the other intent sort of issues come out of synthetic data. And it can be really, those can be things that are very hard to understand for non-technical users. And so at that point you end up in this incredible mess of trying to explain what has gone wrong. And I think that you know, it can be really exciting to think about synthetic data, but it's about looking at the problem. Certain problems are definitely great at it. You know, I don't think we would be where we are in game playing AI if we didn't have synthetic data. But also I think in a lot of the more unpredictable or types of AI, it's not really there yet.